final day of new notes. Again, test isn't till next block day. So for just recording purposes, it's Friday, September 15th, and this is day 5 of the unit, and so it'll be worksheet 5 is the assignment that goes with this one. All right, a to the m over n. Do you remember what the m and the n do? Which one is which? M is the power, and n is the root. The flower power thing. So if you wanted to write it as a root, it would be the nth root of a to the m. Or it could be the nth root of a all to the m. Like those are the same thing. And yes, the flower power grows on top. I'm almost out of room for my beautiful flower. And the roots grow underneath. Flower power on top, root grows underneath. Silly, but hey, if it helps you remember which one's which, then by all means use it. That's kind of it for, that's not even new information, but that's it for the reminder of information. Let's do some examples. Negative 2 to the 4th, especially as compared to negative 2 to the 4th. Right, so number 1 versus number 2. Students miss this all the time. Even if you spot them on a calculator, they miss it because they don't know how to put it in. So I'm fourthing negative 2. So let's answer I think the easy question first. Is my answer going to be positive or negative? Positive, because I'm fourthing a negative number. And then 2 times 2 is 4, times 2 is 8, times 2 is 16. So positive 16. What about number 2? Is that going to be positive or negative? Negative, because exponents come before multiplication. And that negative sign is multiplication. The exponent is the 4. So negative 2 to the 4th we already said is 16. So negative 16. I don't know how to write that any differently. 27 to the 2/3. Okay, so the top number is the power, the bottom number is the root. We usually like to do the root first. It doesn't matter. They're both exponents, so there's not an order you have to do. But I would rather take the cube root of 27 than square 27. I do not know what 27 squared is. But I do know what the cube root of 27 is. That's 3, and 3 squared is 9. If you'd rather square 27 and then get the cube root of whatever that awful number is, the answer would still be 9. That would just be the long way around. So we usually like to do the root first because it gets us a smaller number, easier number. All right, 4 25ths. Well, let's just handle them separately. Let's do 4 to the 3/2 over 25 to the 3/2. This is going to be a place where some of you start skipping steps, which is fine. So that's the square root of 4 cubed over the square root of 25 cubed. I'm going to skip a step here. 2 cubed is 8. 5 cubed is 125. Ooh, negative exponents on number 5. What's a negative exponent do? I would phrase it differently. You're right, it's going to send this one to the denominator. I would just say it flips it to the other side. So if it starts in the denominator, it flips to the top. If it starts in the top, it flips to the bottom. So that negative sign will flip this over 1 over 16 to the 5/4. Again, some of you are going to combine steps and just jump straight to, well, that's the 4th root of 16 to the 5th. So the 4th root of 16, well, we kind of just did that. 2 to the 4th was 16. So the 4th root of 16 is 2. And 2 to the 5th is 32. negative 1 to the 2/3. So that's the cube root of negative 1 squared. Cube root of negative 1 is negative 1. Square it, we get positive 1. That's how we usually work the problem. This one you could do the power first, since it's easy enough. Negative 1 squared, and then the cube root of that, if you want to try the power first. Squaring negative 1 gets us 1. The cube root of 1 is 1. So you don't need to do it both ways, but that kind of illustrates if you do root first versus if you do power first. Hey, it doesn't matter. Just usually it's easier to do root first. All right, now some equations. If x to the 3/4 equals 27, then how do I counter that x to the 3/4? Did I skip something? Oh yeah, it's hidden right here, number 7. Oh, power to a power, which is good because that's going to lead us into number 8.
You multiply the 2 powers.
Multiply the 2 powers. So 3/2 times 4/3. 3's cancel. 4 over 2 is 2. Square the top, square the bottom. You okay?
Multiply the number 8 exponent both sides to 4 times.
Yeah, so to undo that 3/4, I'll exponent both sides to the 4/3. Power to a power, we multiply the powers, but 3/4 times 4/3 is 1, that's why we did that. And then 27 to the 4/3. The cube root of 27 to the 4th, 3 to the 4th is 81. Number 9. What are we going to do to both sides on number 9? Yeah, power them both to 5/4. Exponent them both to 5/4. So the left-hand side looks awful because you got to the 4/5 to the 5/4, but the whole point is those cancel each other out, and we're back to just 2x minus 3. The 4th root of 16 is 2. I feel like we've done that 3 times already today. 2 to the 5th is 32. And now I've got like algebra 1 level stuff here. 2x equals 35. X equals 35 over 2. Number 10. Find the real values of x, if any exist, which satisfy the equation. So solve that equation. What do you want to do first to solve that equation? If you square it right now,
minus 1.
yeah, you'd have to FOIL the left-hand side and you'd have a real mess on your hand. Let's move the 1 over, and then squaring will be a whole lot more effective. I mean, you're always welcome to square both sides, but it would be more helpful to move the 1 over first. So square and square root cancel each other out. What do I have to do on the right-hand side? FOIL, right? That's not just x squared plus 1. It's x squared minus 2x plus 1. So I've got a quadratic. Let's move things around. set it equal to 0 and see what happens. Hope that it factors. But hey, if it doesn't factor, we can still handle that. They were kind. X minus 8 and x plus 1. So x equals 8 and x equals negative 1. But there's something kind of going on in the background here. And that is, if you square both sides, both sides, you see that squaring wipes out the negative, and sometimes that introduces extraneous solutions. So another one of those might issues. If you square both sides, you might get extraneous solutions. And the only way to know is to check them. And they're real easy to check. It's just a matter of if they work or not. So if I plug in 8, I get the square root of 49 plus 1 equals 8. 7 plus 1 equals 8. Yes. Yes, it does. If I check negative 1, I get the square root of 4 plus 1 equals negative 1. 2 plus 1 equals negative 1. No, that is not true. So I have to throw out one of my answers. It's only x equals 8. So if you square both sides, that's the big thing. If you square both sides, you got to check your answer. Number 11. Square both sides. We got 2 square roots here. Well, I don't think I can fix them both at once. So let's square both sides. That'll fix the left-hand side. It'll make the right-hand side worse, but what am I going to do? That's all I got. So the left-hand side becomes 2x plus 1. That's why we did it. That got rid of that one. The right-hand side does not become x plus 1, right? You got to FOIL that. So if you need to write it out, do it. X plus 2 square root of x plus 1. So it cleaned up half my problem and made the other half worse. But I now only have 1 square root in there. So let's move things around to get this square root by itself. So subtract x from both sides, subtract 1 from both sides. So x equals 2 square root x. So I have 2 options now. I could divide by 2 and then square both sides, but then I have fractions to deal with. Or I can say, well, I can handle a 2 in there. That's fine. Let's just square both sides. As long as you know what happens when you square 2 root x, what would you get? 4x, right? You got to square both the pieces. So 4 and x. Okay, all my square roots are gone. Now I can set it equal to 0, hope that it factors. X equals 0, x equals 4. Close up shop, I'm done, we can go home. Not quite. We squared both sides. In fact, we squared both sides twice, so double jeopardy here. I got to check these, and I'm really suspicious that both of these are going to work, but we'll see. So I plug in 0, I get the square root of 1 equals the square root of 0 plus 1. Yep, that's right. if I plug in 4, so that'd be the square root of 9 equals the square root of 4 plus 1. 3 equals 2 plus 1. Yes it does. So they both worked. Sometimes they both work. Sometimes one of each. Sometimes neither. So it just depends on the problem. You always have to check both answers. If you got 2 answers or 3, however many you get, you got to check them all to make sure. So if you square both sides, check your answers. All right, today's assignment is worksheet 5. You got time to work on it. Don't work on worksheet 6 because we'll have time in class Monday and Tuesday, and the game will be fun on Monday. And I think we will attach some reward to it.